Welcome to graphing derivatives. Now, I'm going to skip some parts of this because this is my original function, just a cubic function, f of x equals x cubed, and that's what it looks like, the red graph there. And I'm not going to worry so much yet about gridding this off or plotting points or any of that, because you can see, the shape of this. Well, if we do f prime of x, in other words, if we find the derivative of x cubed with whatever method you want to use, you will get 3x squared. All right, so the derivative of f of x, x cubed, equals 3x squared. And if we make a simple graph of that, I want to show you what happens here and why it works the way it does. Well, this graph here is going to look something like, if I can do it right, like that right there. Except it's going to bottom out right there. And I want to show you how this basically works with the slope of the tangent lines and all that. So if we look at this, and let's say that point right there is 1, and we'll call this 2 and this 3. And over here we'll go out 3 places this way. The slope of the tangent line, say here, do that again. Try it one more time. Slope tangent to that, maybe there. And let's actually color code this. So here's the green. Make that green for 2. So this would be 1, 2, 3. The green line would be, I'm trying to make this as neat as I can. It's not the easiest thing, people. Not the easiest thing at all. So there's maybe a tangent to that. And the last one we'll make purple. Purple. And maybe something like that. And we can see that at 1, the slope of this line is less than the slope of the line at 2, and way less. The blue line is way less than the slope of the purple line. And you can see that. Hopefully you can see that. And then over here, the same basic thing happens. And it's going to be really messy when I do this. Let me just for a second zoom in here, and I'll zoom back out in just a minute. Let's call this -1, -2, -3, so I can get in kind of tight on that. If it passed through, say, that point right there, the slope of this line is actually pretty close to the same as the slope of the blue line. So it's going to be right up through here like that. And then at 2, I'm just going to freehand this. Maybe like this. And then the purple here. Be down here somewhere. And it's going to, let me zoom out just a bit. Something like that. And you can see, sort of, that the purple, I mean, this is just a freehand thing. We're not building parts for the space shuttle right yet. This purple lines are very similar in slope. The green tangent lines are very similar. And this blue, and I don't know why I made it yellow, but the blue and the yellow tangent line are very similar. And if we, you can zoom in on this and kind of see where the blue one is and so on. They're very close to each other. I'm all over the place. I'll get it in a second. There we go. So now, what do we do with this? Well, if I put some, if I make a chart out of this, we'll call it x and f prime of x, where, remember, the specific values evaluated into the derivative are just the slope of the tangent line. So this blue, we could call that maybe, if I had point 1, I could call that 1, let's just call it 1, 1. And then 2, the green line, maybe that's a slope of 3 that looks a lot steeper, like up 3 over 1. And then the slope on 3 here, this purple line is practically straight up and down. In fact, if we went out to 4, it would be really dramatic. We call this maybe 7. I don't know. Just throwing numbers out there. And then on the other side, it would be the same thing. -1, since it has about the same slope, we'll call it 1, -2, and -3. -2 would be 3, and -3 would be the same as +3, which would be 7. If you none of these slopes over here, though, are negative. So if we had to start this over, which I'm going to have an issue with, I'll tell you what I'm going to do, because if I try to erase that, that thing's going to turn white, and I don't want to do that. So let me cut this box out, copy, and then I'll go into a different layer. Make that, whoa. Let's make that color like I want it. And then I'll paste that. Okay. And then we'll move that over here. We can make a graph of the points of this graph so I can show you what it is. Boom. It's hard to do these fast. But if I plot these points, 1, 1, and then 2, 3, and 3, 7. 1, 2, 3, 4, 5, 6, 7. Remember, this is the f prime of x-axis, and this is the x-axis. It would be up here somewhere. And then the other side would follow suit. So here's -1, -2, -3. So that would be here. Looks like here would be 1, -3. Sorry, -2, 3. And then -3, 7 would be up here. And you can see that this creates that parabolic shape. And that's how you can graph sketches of the derivative when you just have the regular function. Remember, though, go back to the original, this, if you find the derivative, you can simply just graph it. But the book's gonna make you match things. Like, it's gonna give you a picture of this, and you're gonna have to say, okay, this shape here would be the derivative of that. And it takes practice, and it takes you to study this video and how all those colored lines and the slopes of the tangent lines work. See you later.